Most predators wait for movement before they respond. Their actions begin only after the target has already changed position and revealed its next move, leaving reaction as the only option. The dragonfly does not follow that rule. It commits to an attack before the prey's movement is complete, while the outcome is still unfolding in real time. Instead of reacting to where the prey is, the dragonfly targets where it will be next. The strike is planned in midair, seconds before contact is made. This ability is not explained by speed alone, and it is not simple reflex. It depends on a neural system designed to predict motion as it unfolds. With a hunting success rate that approaches near perfection, the dragonfly demonstrates a different strategy. In this world, precision beats reaction, and prediction decides the outcome. Among flying insects, the dragonfly stands apart as a near-perfect predator. Its success rate in capturing prey reaches levels rarely seen in nature. In controlled observations, dragonflies intercept their targets with extraordinary accuracy. Missed strikes are the exception, not the rule. This precision is not the result of random pursuit. The dragonfly commits to its attack early, long before the prey reaches the point of capture in open air. Rather than adjusting its path continuously, the dragonfly locks onto a future interception point. Once the attack begins, the trajectory rarely changes. This strategy reduces the need for constant correction. By solving the movement problem in advance, the dragonfly simplifies the hunt before the chase even begins. The prey does not appear to outrun the dragonfly. Instead, it flies directly into the path already chosen for it, as the interception unfolds ahead of time. From the outside, the attack looks effortless, but beneath that smooth motion is a precise calculation unfolding in real time, hidden from view. To understand how this is possible, we need to look beyond wings and speed. The true advantage of the dragonfly lies inside its neural system, where prediction replaces reaction. The dragonfly's advantage begins with vision. Its compound eyes occupy most of the head, capturing motion with exceptional spatial coverage. Each eye is built from thousands of individual lenses. Together, they create a visual system tuned not for detail, but for detecting movement. This design allows the dragonfly to track multiple objects at once. Targets remain visible even as the insect rotates, dives, or changes speed. But seeing motion is not enough. The real advantage comes from how that visual information is processed and used to guide the attack before any reaction is required. Instead of continuously recalculating the prey's position, the dragonfly predicts its future path. The brain selects an interception point ahead of time. Once this prediction is made, the dragonfly adjusts its own flight to meet that point. The prey's movement becomes part of the solution, not a variable to chase. This reduces the need for rapid corrections. Fewer adjustments mean faster decisions and greater accuracy throughout the entire interception process. Neural pathways in the dragonfly are optimized for speed and efficiency. Signals travel along short routes with minimal delay, reducing processing time during flight. This shortcut allows prediction to happen in real time. The dragonfly does not wait for new information before committing to the strike in midair, even as conditions continue to change. As a result, the prey appears to fly into danger on its own. The interception feels sudden, but it was decided moments earlier in the air, before contact ever occurs. This system works best in open air, where motion follows predictable paths. In these conditions, prediction consistently outperforms reaction. The dragonfly does not need to be faster than everything it hunts. It only needs to be earlier, committing to the outcome before the chase truly begins. In most predators, time is the main limitation. Reaction begins only after movement is detected, placing every decision one step behind the target. The dragonfly removes that delay entirely. By predicting motion, it shifts the hunt forward in time, acting before reaction is ever required. This creates a decisive advantage. The dragonfly is already committed to an interception before the prey reacts or begins to change its path in response. From the prey's perspective, escape options collapse rapidly. Every evasive move still leads toward the same interception point ahead, no matter which direction it chooses. The Dragonfly does not need to constantly update its plan. Prediction reduces uncertainty instead of chasing it through constant adjustment during flight, conserving time and precision. This efficiency lowers cognitive load. The brain does less work while achieving greater precision throughout the entire hunting sequence in midair, under rapidly changing conditions. In effect, the Dragonfly experiences motion differently. The world appears slower because outcomes are decided earlier, before movement fully unfolds. Speed still matters, but it is no longer the deciding factor. Timing becomes the true weapon that determines the outcome of the hunt before contact is made. By acting ahead of movement, the Dragonfly controls the encounter. The hunt ends before it fully begins, with the outcome already decided in advance. This advantage is not unique to one strike. It defines the entire hunting strategy of the species across every encounter in the air, from the first approach to the final capture. The Dragonfly does not understand physics, mathematics, or prediction. It does not know that it is solving a complex motion problem every time it hunts. Its advantage is not intelligence in the human sense. It is a body shaped by evolution to make the correct decision automatically, without conscious thought. Over millions of years, individuals that predicted motion survived more often. Those that reacted too late disappeared from the population entirely. What remains is a system that acts before hesitation is possible. Precision emerges without awareness or intent, shaped entirely by biological design. This strategy works because the world obeys physical rules. Motion follows patterns that prediction can exploit across time and space, as long as those rules remain consistent. As long as those patterns remain stable, the Dragonfly remains unbeatable in the air. Its success is built on consistency, not flexibility. The hunt ends not with speed, but with timing. The outcome is decided before the final movement is even visible to either hunter or prey, long before the moment of contact. In the Dragonfly, we see a different form of mastery. Survival does not always belong to the fastest reaction, but to the strategy that acts first in time. Sometimes it belongs to the organism that arrives first in time, even if it never knows it did and never understands the advantage that decided the outcome. The Dragonfly system works because motion is predictable. Air, speed, and trajectory follow physical rules that rarely change over short moments in flight. In this environment, prediction is more efficient than reaction. The future becomes easier to hit than the present because the decision is made before movement fully unfolds. But this advantage has limits. Prediction only works when the world behaves as expected, following patterns that remain stable and repeatable over time. Sudden turbulence, visual noise, or chaotic movement reduces accuracy. Even a perfect system depends on stable conditions to maintain its precision. The Dragonfly does not adapt its strategy in real time. It relies on patterns that evolution has already tested and refined over countless generations. When those patterns hold, success remains near perfect. When they break, the system has no backup to recover or adjust in time, leaving no margin for correction. This reveals an important truth about biological intelligence. Precision does not require awareness, but it does require consistency over time to remain effective. The Dragonfly does not improve with experience. It does not learn from failure or adjust its calculations during the hunt, repeating the same strategy every time. Instead, its success exists at the species level. Millions of attempts refine the system long before any single hunt begins in the air, across generations of trial and survival. What looks like intelligence is actually refinement across time. Evolution performs the learning, not the individual, shaping the outcome long before each encounter begins. In the Dragonfly, prediction replaces thought. Timing replaces decision, allowing the outcome to be determined before conscious choice is ever required. And in that silent efficiency, the hunt is already over. Not because the dragonfly reacts faster, but because it arrives earlier in time, long before the moment of contact.